Today, drones are playing a pivotal role across industries. These flying marvels can soar to great heights and do incredible tricks up in the air. Ever wondered how? That's where the embedded system comes into the picture.
So let's keep the things very simple to begin with. Let's compare the drone to a bird. So the body of the drone you can compare with the body of the bird. The landing gear of the drone you can compare with the legs of the bird. The propellers on the drone you can compare with the wings of the bird. The battery on the drone you can compare with the heart of the bird. And finally the avionics you can say is the brain and the entire nervous system of the bird. So the avionics in a drone comprises of many sub-modules, starting with something we call the autopilot. This is the device which has the sensors like the accelerometer, magnetometer, pressure sensors and many other sensors and incorporates the main brain of the avionics. Second, we have the ESCs, also known as the electronic speed controllers, that is used to control the speed of the propellers attached to the drone. This also helps in controlling the pitch, the roll, the yaw of the drone, and you can control the overall speed of the drone using these ESCs. Then comes the GPS, also known as the Global Positioning System. Its duty is to provide the latitude and longitude or the position of the drone and time, the speed and course, and also gives the altitude or the height of the drone above the ground. Next, we have the obstacle avoidance or collision detection sensors. These help in avoiding the drone from colliding or crashing into any obstacles. Next, we have the wireless system, or you may say the radio system, which help in transmitting the data or the video or even the remote control commands to and from the drone and the ground station. And like a plane, drones are also fitted with left and right indications, also known as port and starboard indications. This helps to tell the direction of the drone to the user down below on the ground. All these systems or all these avionics sub-modules in the drone communicate with each other using standard protocols like SPI, I2C, UART, CAN, Ethernet, etc. Yeah, so drones are available in various kinds, and that is specifically depending on the application the drone is being used for. For example, it could be used in search and rescue, surveillance, mapping, agriculture, farming, crowd control, traffic control, cinematography, and so on. So what's going to differentiate each drone from each other is the payload or the external avionics attached to the system. This payload decides what application the drone is going to be used for. For example, you could use gimbaled high-resolution video cameras for surveillance, mapping, etc. You could use announcement system for traffic and crowd control. You could use a water and pesticide spraying mechanism for farming and agriculture, or you could use pick-up and drop mechanisms, say for transportation and deliveries. So by challenging environmental conditions, the most harsh ones are heavy winds, heavy rains, extreme temperatures, be it extremely high or extremely low temperatures, and sometimes even high altitudes are a kind of harsh environments for the drone. So usually for mild and moderately mild environments, the autopilot may take care of the situation, but in case of extreme conditions, the drone may have to be returned back to the landing station, or it may also make an emergency landing. So for quality assurance, we make sure that each component and module used in the drone is being tested for its operating extremities. Also, once the components are developed, we see that they pass through a lot of verification and validation tests and also environmental tests. And finally, once the drone is ready, we do multiple flight tests to see that finally the drone operates successfully without chances of field failure. To name a few, technologies are being used where drones can be controlled by the ground station even beyond the line of sight. There are GPS-denied navigation systems being deployed into drones that help the drone reach its destination even in the absence or the jamming of the GPS system. Energy-efficient propulsion systems are being utilized that provide improvements in the flight endurances required for longer missions and increased coverage area. Various kinds of fuels and supply sources are being used besides the traditional battery packs, which power the avionics, helping as an alternate or backup energy resource. Then there are underwater drones, drones as signal repeaters, and the list goes on and on. These are a few that I feel are the most exciting changes. Well, undeniably, what we find most motivating and rewarding is that what we make is being used by the defense and security forces. And we feel very happy that whatever we are contributing to the country's safety by whichever small means we can, and that makes us really, really happy.